Hello, and welcome to part 2 of the Logistic Regression of Python lecture series. In part 1, we focused on exploring the data through visualizations in their exploration, and we actually found that we had some missing data. So what we want to do now is switch gears to cleaning our data. So cleaning our data will allow us to transform our data into an acceptable form for our machine learning algorithms. Let's go ahead and jump right back to the Jupyter notebook where we left off last time. So here I'm at the Jupyter notebook. If you remember from last time, we went ahead and used a little trick with the trained data frame. We call the method is null, right? And we use the heat map to show train dot is null, right? So and we know which column is missing data. So what we want to do is we want to fill in the blanks. Okay, fill in the empty cells. Okay, I will say in this case we are talking about the age column. Okay, one way to do this. Okay, one way to do this is just by filling in the mean average, the mean age, the average age of all the passengers. This is called imputation, and that means you could just take the average age and fill in the missing values with the average age. However, we can even be a step further. We can be a step smarter. So we check the average age within passenger classes. So what do I mean by passenger classes? As I said, if you want to fill in the blanks for some columns, so in this case age, right? So you're gonna see which feature has the potential influence on age. And based on the common sense or based on the exploration, the EDA you did, for the previous EDA you did, you might think, okay, P class, passenger class, it might have some relationship with the age. I might use that to determine what value should I put for age, right? So let's just scroll down and I will draw a box plot for that. Okay, so to draw a box plot, I'm gonna use Seaborn library called Seaborn library. And box plot, I'll take the x as P class. That's what I'm interested in, right? And y will be my age column. And data is just a train data frame. Okay. I think that's a bit too small, so I'm gonna adjust the fix size a bit. So to do that, we're gonna plt figure fix size. Oops, fix size. Oh, what should I put? Maybe 10 by 7. I just want that to be a bit larger. Yep. Okay. Now we can kind of zoom in on the center point of sectoral box plot. Okay. So we can see here, when we separate by class, the wealthier passengers in the first class and the second class, they tend to be actually be a bit older than the passengers in the third class. You see that? Now you may think that this kind of makes sense because maybe the wealth that in order to reach the first or second class tiers, it takes age or time to accumulate. So if you have enough time to accumulate enough wealth, it will be older and more likely to be in the first class. Well, what we can do is use these average age values in order to impute the age based off the passenger class. Okay. Now, if you want it, you could create the entire model to try to predict age based of all the features. Okay, you will go ahead and use the sort of simple imputation, which is a little better than just imputing the average age, right? Let's go ahead and create a function. Okay. Okay. So let's create a function. All right. So def define, and I'll call the function name impute age, impute underscore age. And what argument should I take this time? Okay, so it will be the column will be, sorry, the argument will be some columns, right? Some columns. I know in this case is the age column and the passenger class, these two columns. So I will just say that the arguments will be some columns. Okay. So the first one, I want to pass. Okay, I'll take some columns, and I will take the first column, or pass the value to age. To represent that, I'm going to use the index. So cos index number 0, which means the first column will be passed to age. Okay. Don't worry if you didn't understand this one here. Okay, and the next one will be P class, and that will be the second column. So it's cos 1, right? And then I'm gonna use the if statement. Okay, that will help me to check what. So if pandas dot is null. Okay, so this if statement is used to check is this current cell null. Okay, if it is null, okay, we are going to use the inner if statement. I'll say if P class is equal to 1. So if the passenger is in the first class, we're gonna return what age should we return? Okay, as we said, we're gonna use the average age in different tiers passenger class, right? So this one will be 37, around 37. So if you want to be more precise, what you can do is you call the main method to help you, right? You call the pandas library and dot main, and you can get exactly what is the average value for that. But I don't think that is necessary for this one, so I'm just gonna give the approximate number. Okay, so if the passenger is not in the first class, then we'll give the second condition. So elif P class is equal to, what should we return? What age should we return? Okay, so it's 29. Okay, if neither, okay, none of the conditions, condition 1 and condition 2, okay, neither of them are met, so we go to the third class. So else, oh sorry, I forgot the column here. Yeah, so else, by looking at the box plot, will be return 24. All right. Okay, so this is the inner if else statement. Okay, so let's go to the outer if statement. So if the current cell is not null, okay, then what will return? We just return the age. Okay, we don't do any modification to that. Okay, we just keep that the same. Right. So now let's apply the function. Okay, so the function will be applied to which column? The age column. So train age equal to, okay, as I said, I'm taking care of two columns, age and p class, right? So in this case, my function will be applied to age and also p class. Okay, and don't forget about this will be a list of two columns, so don't forget about the square brackets here. Okay, then apply. Okay, so what argument should I put? Okay, in this apply method. So the first one will be the function that you want to apply. So what's the function name? Impute age, right? Impute age. Okay, and I'm gonna add 1, access is equal to 1. So that means this is applied to the column. Okay, this is applied to the column. If that is 0, that is applied to the row. Okay, let's run that. Input, oh sorry, I didn't run that. Okay, so let me explain that again. So what I did here is I defined a function named impute age, and it takes some columns as arguments. So in this case, you know that it's taking the column age and the column passenger class, right? And what I did is I'll say the first column here I take, okay, in the argument, the first column will be passed to age, okay, and the second column will be passed to p class, okay. And then what I did is I did some comparisons here. Okay, I said is, so the first thing I check is the current cell null? If not, I just we don't do any modification, we just keep the data, okay. But if the cell is null, we want to fill in, right? So then we check, is this cell the passenger class of that cell, is that the first class? If it is, we return 37, the average age of the first class. And then the same thing here, the second class, the average age for second class is 29 and 24 for the third class. Okay, so now what we do is we're gonna check the heat map again to see if all the age, all the cells in the age column has been filled in. So symbol library, heat map. Okay, so what should I put here? The same thing. So if we have to check if the train is that null, right? We're gonna use the same thing here. Hopefully we can have all the age column, the sticks gonna be removed. Yeah, perfect. Okay, all the sticks has been removed from the age column. So we did fill in all the cells for the age column, which is good. Okay. But we still have cabin left. Okay, we have cabin left. But you know that we got a lot of data missing, right? We got a lot of data missing. So instead of filling the missing data, I strongly suggest you either switch this column to cabin none. So it will be 0 or 1, right? Do I know the cabin? Or otherwise, I suggest you just drop that off. Okay, so let's just drop that off. So to drop a column in a data frame is using the drop method here. So pass the name of the column, cabin, and access is equal to 1 to indicate the column in place is true. Okay, question here, what does in place mean? Okay, so the default So the default for in place is false. But what does that mean? We've been using that in the previous pandas the data frame lecture. Do you remember what does that mean? Okay, so in place is like if you set that to true, there will be no return. Okay, there will be no return, and the data has been updated. If you use the default, you set the in place to false, then that will return the copy of the object. But I don't need that here, so I just set the in place to true, so we can check our data to see if the cabin column has been removed. Oh, I didn't run that. Okay, great. This column has been removed. Okay. And let's go back to check the heat map. Okay. Right? It seems like all the missing data has been either filled in or being dropped. So this part 2 is just a basic lecture for how to do the data cleaning. Okay, so the part 3 we will start do the model, how to train the model, and we'll talk about how to convert categorical features, and we'll talk about how to build a logistic regression model, pretty similar to linear regression model. See you in part 3.